Hello and welcome to our lesson on the division properties of exponents. Now, before I begin, I'll say ignore the page number and problem numbers up here in the corner. That was from the regular school year, not applicable to our summer school course. So just disregard that in the upper right corner. Now, obviously, our goal is to use the division properties of exponents. And those two main properties you can see right here. So one of the main properties is known as the quotient of powers property. Now remember, quotient would refer to a division problem, so we know we're dealing with division. So division of powers is how I think of this. So if we have something to a power divided by the same number to a different power, the rule is you keep that base number and you subtract the exponents. So if we think back to our addition rules or our multiplication rules, we had to add the exponents when we were multiplying. Now when we are dividing, we have to subtract the exponents. Then we have the power of a quotient property, which states if we have a fraction to a power, we can separate the numerator and denominator, and both numbers or values can go to that power. So if we look at our examples here to try to make sense of these two rules, example 1, part A, we have 6 to the 5th power over 6 to the 4th. So we're going to use our quotient of powers property and subtract the exponents. 5 minus 4 is 1. So it'd be 6 to the 1st power, which is just 6. In B, the negative 5 is in parentheses on top and bottom, so we'll leave it in parentheses. Subtract the exponents. 2 minus 2 is 0. Negative 5 to the 0 power, anything to the 0 power, as we learned in our last lesson, is 1. Now in C, we have 9 to the 4th times 9 to the 2nd on top. So right away, I'm going to add those two exponents, which would give me 9 to the 6th on top over 9 to the 7th on bottom. So then my problem becomes 9 to the 6 minus 7, which is 9 to the negative 1st power. Then if we have something to a negative power, we move that to the bottom of our fraction. So it'd be 1 over 9 to the 1st power, or 1/9. And in D, we have 1 over y to the 5th times y to the 3rd, which I rewrote as y to the 3rd over 1. So if we multiply top and bottom, we end up with y to the 3rd over y to the 5th. So we are going to use our quotient of powers property and subtract the exponents. 3 minus 5 gives us y to the negative 2nd, which we can rewrite as 1 over y squared. Now, example 2 is just applying some of these rules. Again, now this time we are mainly going to look at the power of a quotient property. So if we have a fraction going to a single exponent, we can split the top and bottom. So if we look at part A, 2/3 to the 2nd power can become 2 squared over 3 squared, or 4/9. In B, negative is inside the parentheses, so I can apply it to the 3 or to the y, not to both. So I applied it to the 3. So on top, we'd have negative 3 to the 3rd power over y cubed. Negative 3 to the 3rd power is a negative 27 over y cubed. And then in part C, we have 7 over 4 to the negative 3. So before I worry about doing anything with the negative, I'm just separating top and bottom. So I have 7 to the negative 3 over 4 to the negative 3. Then, because both are negative powers, I'm going to bring the 4 to the negative third to the top and the 7 to the negative third to the bottom, which would give us 4 cubed over 7 cubed. Then 4 cubed is 64, 7 cubed is 343, so we have 64 over 343. Then example 3 starts to blend all the different rules and properties that we've gone through together. So we'll be looking at some of our multiplication, some of our zero and negative, and some of our division properties. So anytime we're dealing with complex problems like this, for example, in A, two different fractions being multiplied, the first thing I do is simply combine like terms by multiplying across the top and the bottom where I can. So on top I have 2 and 9, so 2 times 9 is 18. X squared and a regular x would be x to the third. Y to the first and y squared would also be y to the third. Then on bottom, the 3 has no other number to go with, so the 3 is still there. The x has nothing to combine with, same with the y to the fourth, so my bottom is just 3x y to the fourth. Then I want to simplify top and bottom. 18 divided by 3 is 6. X to the third over x. Subtract the powers. 3 minus 1 is x squared. And then the y's, subtract the powers also. 3 minus 4 is a negative 1. So right now we have 6x squared, y to the negative first. Now we don't want that negative 1 with the y, so we can move that to the bottom of our fraction to get rid of the negative power. So we end up with 6x squared over y. Now in part B, we have a fraction going to a power. So I'm going to split my numerator and denominator first. So on top, I have 2x to the fourth. On bottom, I have y squared to the fourth. So on top, 2 to the fourth is 16. And then x to the fourth. So we have 16x to the fourth. And on bottom, 2 times 4 for the power is 8. So we have y to the 8th. Can't do anything further with this one. Then we get down to C here. In C again, it's a fraction to a negative power. So I am splitting my top and bottom, and at the same time, I'm going to flip the top and bottom so I can get rid of the negative power. So the 3xy moves to the top, and our top, 2x cubed y to the fourth, moves to the bottom. Both are still to the second power, just became positive because we flipped it to get rid of the negative. Then I'm going to apply the powers. So 3xy to the second power becomes 9x squared y squared. And on bottom becomes 4x to the 6th, y to the 8th. Then we'll look to simplify. Can't do anything with 9 and 4, so that's still 9 over 4. X squared over x to the 6th would give me x to the negative 4, or x to the 4th on bottom. And then y squared minus y to the 8th is y to the negative 6, so I leave that as y to the 6 on bottom. So our final answer, 9 over 4x to the 4th, y to the 6th. And then in D, my first fraction, I'm just going to leave alone at first. And the second fraction, I'm going to apply the power. So the first fraction I just rewrote. Second fraction, everything went to the fourth power. So the top became x to the 12th y to the 8th over 4,096, 8 to the fourth power, then x to the fourth, y to the fourth. Now what I did was I combined my numerators and denominators to make all one fraction. So 16, x to the 5th, x to the 12th gave me x to the 17th. And then a negative 8 plus a positive 8 was 0. So y to the 0 goes away because that's the same thing as 1. On bottom, x to the 7th and x to the 4th gave me x to the 11th. Y to the 4th and y to the 4th gave us y to the 8th. And then we still have the 4,096 in front. Now that it's all one fraction, I want to look to simplify and combine like terms. 16 over 4,096. Both can be divided by 16. So I have 1 over 256. X to the 17th over x to the 11th. Subtract the powers. 17 minus 11 leaves us with x to the 6th. And then on bottom, we still have y to the 8th. Now, I could leave the 1 there or get rid of it. Doesn't matter. So our final answer is x to the 6th over 256, y to the 8th. Now, as you can see with this lesson, we start to blend all of our different properties and rules together. So as you're working on the practice problems, you are going to want to take your time, look back at the previous properties, practice problems, really go through step by step and make sure you're showing your work each step along the way like I did here so that you don't miss a step. And again, use the selected answers in the book if need be to check as you go to see how you're doing on the practice problems and reach out to me with any help you may need.